Yeah, sorry for this. Thank you so much for understanding. Let me share my screen very quickly. Yeah, hey, by the way, my name is Rohan, and thank you so much for tuning in tonight. Very warm welcome to this masterclass hosted by Interview Kickstart. Tonight's topic is around demystifying LLMs. How should you go about choosing the right LLMs for your projects, for your uh, any new things that you're building? My screen is visible, right? Quick yes in the chat would be super helpful. Um, There is echo. Somebody is saying there's echo. I hope there's no echo for everybody. Just like one off use, one off case. Cool. I'll quickly get to it. So before I dive into it, I'll just quickly set the context. What we are doing today here is we have like a great 90-minute session lined up with Dr. Nahid. She'll walk us through how should you go about choosing the LLMs. Very quickly, the agenda for tonight being, we'll start with introduction to Interview Kickstart. It will help us act as a filler for like 2-3 minutes before most of the folks tune in. After that, that is when Dr. Nahid takes over. She'll start with understanding the landscape of modern LLMs. What are the key factors that you should take into account while choosing the LLMs? How should you go about applying a systematic framework? Then we'll take like a pause for the Q&A, and then over there we'll briefly talk about Kickstart's offerings and the market landscape. And then eventually she'll again take over and go through like how should you go about fine tuning, distinguishing between fine tuning and RAG approaches, and then essentially making informed decisions for your specific use cases in the real world. Real world. Before I do that, there is one thing I really want to call out. Let me just run a very quick poll. Just one second. Just one sec. Yeah. There is a special event that we are doing on 10th, 11th, and 12th of October. I'm launching that poll. Don't address it straight away. Just understand first. Uh, it's about AI Launchpad. It's about transitioning to AI with practical skills and FAANG plus mentorship. It's a free event. There are no charges. It's a 3-day boot camp. I'll quickly give you the agenda walkthrough as well, like what will happen on that day. Again, Dr. Nahed is also going to be a part of that particular session. There will be a 3-day piece. We'll start with understanding. It is predominantly for people, let's say, who are looking to upskill to AI already in the like later stages. It will have like 5 key master classes with FANG Plus instructors. Day one would be around what are the key foundations. Day two, how do you go about identifying the LLMs? Day two first masterclass would be on how do you go about building your first AI agent with a live demo. And then day two second masterclass would be around how do you go about building multi-agent workflows. And then on the final day, which is 12th of October, it will focus on how do you move from demo to deployment. And then there'll be AMA with the subject matter experts or speakers. We have like an esteemed panel with us. We have Suhrit Deshmukh, Nahid Farhadi, Somashish Goswami, Ahmed El Baguri, and Elias, and all of them are currently working at Fang Plus companies. Again, this is free of cost. There are no charges for this launchpad. If you're interested to attend this, please drop in a yes. We'll be happy to send you the registration invites and the links as well. And if somebody has like prior commitment, it's totally understandable, or the topics don't seem relevant to you, then that's also understandable. I'll keep the poll on for another 5 seconds before I turn it off. So if you want to attend, drop in an answer, give it like respond via the poll, please, not via the chat. That will help me capture the responses easily. I'll refloat the poll once more in between of the session as well. Um, just ending the poll in another 5 seconds, please. 1, 2, 3, 4, 5. It was a very quick 5 second countdown. Yeah. Coming to next piece, Nahid, before walk people through, I'll just run a very quick poll. Another one. I love my polls. I'm so sorry. It's about understanding our audience. Folks, this is just for us and Nahid to understand who she will be addressing tonight. First piece is what best describes your short-term slash long-term career goal or learning goals. This will help us understand who you are, what are you looking for. Second is how AI ready are you? This helps us cater not just to you with regard to the right sessions. For example, if I were to give you context about today's session, demystifying LLMs, based on a poll so far, most of the people early are either 40 to 50% of the people are in the early stages. They are just starting or learning to work with the LLMs. That makes sense that the topics that we host are catered to the audiences that are tuning in for these sessions. And third question is if you would want to know more about our offerings, know more about new Kickstart, we'd be happy to give you a personal consultation. That being said, question one, question two, super, super, super important for us. If you could respond to at least the first two questions, it will help us not just cater to you well today, but also with the future sessions as well. Without further gap, I'll just very quickly give you the heads up introduction to Into Kickstart. We are a decade-old company. Um, Sorry. So yeah, we are a decade-old company with more than 25,000 plus alumni who are currently working in tier one and FAANG plus companies. In terms of interview kickstart, we are a go-to platform for AI upleveling and interview preparation. Uh, in terms of the outcomes over the decade, we have now more than 24 plus curriculum offerings, which we cater to, be it on interview prep side or be it on AI upleveling. The compensation that we see for the people who go through our courses is somewhere on 250K on an average and all the way up to 1.26 million in cash plus equity. We are proud to say that we are partnered with more than 700 plus FANG plus instructors. Of those, there are 70 plus dedicated AI ML instructors. And the good part is these are senior folks in FANG plus companies with average experience of 13 years per instructor. Like I mentioned, these are hiring managers, these are recruiters from FANG Plus in the leadership position. They're working closely with us, not just in curating our curriculum, they are the ones who are delivering it as well. And one such subject matter expert with us today is Dr. Nahid. She's done her PhD currently. She's 15 plus years experience in IT security and privacy, 10 years in different areas of consulting, financial and big tech. The brands you can see, she comes started with all those brands. Like she's worked at Microsoft, Google, Capital One, Accenture, the universities, anything you can name it, she has it, I would say. And again, I don't think I can do justice to your intro. I would really appreciate if you could walk folks through once you take it live. Yeah, I think that is all from me. I'll stop sharing my screen. Over to you, Nayad. Before you start, I'll just very quickly give you what people have responded to. In terms of their short-term slash long-term career goals, there were three options. I don't think you'll be able to see. I'm not ending the poll. There are three things that people had option for. One is transitioning to AI roles, cracking FANG plus tech interviews in the AI era, and upskilling in their role with agentic and Gen AI. 80% of the folks here are interested either to transition to AI role or upskilling in their existing roles, with upskilling in their existing roles taking the primary edge. Second is how AI ready are there. And I think our session today is spot on. Almost 60% are saying they're just starting or to learn working to, and they're just starting learning to work with LLMs. The remaining 20% are boosting productivity with AI co-pilots. There are a handful of folks who are working with advanced ML and deep ML models as well. Over to you, Nahid. I'll shush. I'll be off out of your way. If there's anything, do let me know. I'll be here.
All right. Well, thank you so much. Are we going to close the poll now? Is it still
I'll keep the
showing?
poll. Do you want to run any poll? I'll keep the poll running for some time. Uh,
Okay. All right. Sounds good. Hi everyone, and welcome to today's session. We are focusing on demystifying large language models. We have a full schedule, and there are multiple takeaways from today's session. First, we will understand the sorry. First, we will understand the landscape of modern LLMs and in the last 2.5 years, probably more than 3 years, everyone's imagination has been captured with large language models. Now the trend has moved more into AI and agentic AI. So we'll really look at what the landscape looks like today for modern LLMs. We will identify what does it take to find the right LLM for your use case in your organization. We look at the systematic frameworks, and we would apply kind of like to help in choosing the right LLM for the right use case. And we will distinguish between what is fine tuning and what is RAG. And there are different schools of thought when it comes to using retrieval augmented generation or fine tuning. So we look at both approaches and see what might be the right fit in your use case. And we'll basically wrap up today's session and with a demo. And hopefully there will be a lot of learnings to it. Um, yeah, so a little bit about myself before we jump. I got my PhD from Virginia Tech, currently with Microsoft, and I also continue teaching cybersecurity and machine learning in different universities. Recently, also on the side, I am the CTO at Genie, which is a platform for helping everyone learning how to navigate leadership conversations. And actually fine tuning is one of the main technology behind Genie. So I'm very glad that by this coincidence and the fact that we get to talk a little bit about fine tuning. All right, so getting into some basics, what is an LLM? By definition, LLMs are AI systems which are trained on a huge corpus of data. And what I mean by a huge corpus of data is you can think of a good chunk of the data is used to train these large language models. And when you really look at what's inside these models, it's really a neural network with billions and nowadays moving towards trillions terms of scale, since these are kind of like general purpose sort of large language models. They are trained on huge chunks of data, and these data are of different types, and they really have like a lot of versatility in terms of the tasks they can provide. So you can ask them to write a story for you, or you could ask it for you to generate code. You could ask it to plan your vacation. You could ask it to summarize your data, translate. So modern LLMs can do a lot of different tasks without any sort of specific training, because based on the data that they have seen, they can actually produce fairly reasonable output based on the training that they have. In terms of some of the capabilities nowadays, we are starting to see things like reasoning as well. And this is getting added in the recent models. We also see previously LLMs were primarily had a cutoff date, and now they actually do some searches. They get real-time data from the internet and augment it. Even if they do have a cutoff, they can augment the response that they can provide. And another key to understand when it comes to LLM is that they do have a fixed content, which means that they can only remember your conversation to a certain point, after which the context, it's like a rolling window, terms of context, which it rolls off, and that's when you can start seeing responses deteriorate. So it's something that we will talk more about in terms of what the context of LLM is really is. So in terms of actually building these LLMs, there is a process known as pre-training. So LLMs really, what they are really good at is that they are good at predicting the next token. And you can think of tokens as either it could be a portion of a word, or basically end up with a word. And the reason why LLMs use tokens is because they're large language models. So they're models and they don't understand text, and computers basically work on numbers, not text. But computers are great with numbers, and that is where token comes in. For example, if we are, for example, to take English language as an English has around, I believe, 600K words in the dictionary. And what these tokens and the way that these tokens work is that each word gets assigned a combination or a vector of numbers, and you can think of it as the very fundamental where each word is, assigned, like what each word is gets assigned with a number. And these large language models are trained, and they are fed these chunks of data, and they start seeing different patterns in the neighborhoodness of those words, or what we call tokens. And they start learning, and patterns from these massive training data sets will be stored in their memory. That's how they really get good at predicting the next token based on what they have seen before. So you can also do fine tuning with the LLMs, and what this really does is that it helps the LLM to adapt to now specific tasks. Or if you want to give your LLM a specific personality, like what we do in Genie, or if you want to make it aware of a certain domain where that's, for example, healthcare or financial services or manufacturing or any sort of specific industry specific knowledge that is, you can actually train these LLMs using that data. And really, the intent is when you look at the whole work that is going to be doing industry, we eventually want these models to be helpful, like an assistant, where they will help with whatever task or questions that we have. So they cannot just rely on general knowledge. So when we look at, basically when we open an LLM, what we see fundamentally in the model is basically two files, which is an oversimplification. So we really have, some parameter file where you can see in the diagram, and in the parameter file basically is where the parameters for the neural networks are actually defined. So these are the weights that define the structure, architecture of the neural network. And then you also have a small, what we call a runtime. So this is a program that basically runs, and when we look at any of the popular companies like OpenAI or Anthropic or Google, what they really do is that they put an API in front of this runtime and basically expose that API where we query and we ask questions and we communicate with. And then this runtime is going to talk to the parameter file. And the main question is that how do we really get this parameter file? And to get the parameter file is through the process called pre-training. And this really involves taking a huge chunk of the internet and really running it, running through it. And this pre-training process involves using large clusters of GPUs, and in some cases, these are running on hundreds of thousands of GPUs. And the pre-training process can run for several weeks. Sometimes it can run for a really long time. That generates the base model for us. And so this process is very compute intensive, it's very expensive, and really few companies can afford to build these base models. Now, if we want to look at the core capabilities for LLMs, what do they really do good at? Well, they are really good at generating text. So things like whether it's creative writing, whether it's being able to generate code, whether you want to do some sort of, conversational, give conversational aspect to it. So this is where, like somehow like the concept of assistant model comes into the picture. And so when you have a pre-trained model, generally what happens is You have some human beings who basically write up different sample conversations, and then they use that to train the model to build actually an assistant model. So if, for example, we look at ChatGPT or any of the mainstream models we can have conversation with, they basically have some pre-training, and that's been created by human beings, and that's fed to these models, and these makes them helpful assistants. So LLM technology is now, very rapidly evolving. It does have, some limitations, and as we speak, some of those are being overcome. But the number one problem with almost every LLM out there is basically hallucination. A lot of these models will do a prediction like for the next token. They're very probabilistic rather than being deterministic. So when, for example, we look at like most computer systems, and even if we are building or doing like some sort of traditional development, traditional programming, most of our use cases end up being very deterministic, which means if you have a standard set of input, you're going to see the same output even with multiple repetitions, and because of the fact that this is deterministic process. But with large language models, they are more probabilistic. So you might see the different answers based on how the data flows through the neural network, which layers and which weights are fired, kind of like in the architecture. They can sometimes give you, for example, different responses, so that sometimes leads to hallucinations where the model might make up something, and it may not be true. A lot of the models still have a knowledge cutoff, and they try to offset it by running a new query on more modern models, but or they can do some sort of web search and try to pull some latest information. And even when it comes to some type of computational reasoning, popular, or for example, they may see some popular post on social media, but that may not be factual, right? So these are all problems, and so but they're getting better now. But we still, struggle with some computational reasoning. But we have seen, right, in with different companies that they have generated really, really powerful models. So again, I want to talk a little bit about open source versus closed source models. When we look at models like, for example, models with OpenAI, like GPT, there are some open source models like GPT OSS. We have LLAMA. We have Mistral. Mistral actually has both of them, and they have an open source and closed source model. And we again, same thing, for Gemini, for Google. There are pros and cons with each sort of these options. With the open source models, you have the model is basically open source, so you have access to all of the details of the model. You will get an understanding of what the weights are in the model, what data was used to train the model, and that's really what makes it open source. And with the closed source models, they really don't share much information other than, giving an API endpoint and giving you documentation on how to use it. And basically, we are all consumers. We really don't know what the weights are. We have no idea how to change the weights for those models, and we don't know even what data they use to train the model. So there's really, big difference between open source and closed source. Open source gives us, of course, a lot of control. They are customizable. And when it comes to, proprietary models, these are very heavily funded companies. So they have a lot of resources at their disposal. So, they have new features, new capabilities very rapidly. And these are, one of the benefits. If we go with the proprietary models, we can either, host them some standalone hosting, or we can either host them ourselves. We could either run the model locally or on-prem, or even in the cloud where we manage it ourselves. And we can even create an API endpoint for it. Um, Finally, looking at it from a cost perspective, the open source models, and we'll see, there are different scales. So there is sort of, if we are able to basically plot and predict our usage, we will see that on a graph, depending on the company and our use case. When you hit a certain amount of usage, the proprietary model or the closed source model can get expensive over time as we are consuming more and more tokens. And we'll look at more of these decisions when we want to decide whether we should host locally, what should we do. But once we get into larger volumes, the property models can really get really expensive. And that's where, open source models will help, and they have a fixed cost. And it doesn't matter what is your usage. If you're having, 5 million requests a day, or if you have 1 million requests a day, it's probably going to cost almost the same, except the infrastructure cost that is locally or on the cloud hosting our model. So we do have to, to keep these in mind when we are making decision. When it comes to size, we do have different size of the models in terms of the parameters in those models. We have smaller models, like which is like from 1 to 7 billion parameters, and we have medium sized up to 70 billion. And then there are large models which go into, in some cases even hundreds of billion, approaching trillions of parameters. And one thing to remember is that the biggest model is not necessarily the best model for your use case. So you really want to make the selection based on your use case, and what industry you are in, what application you have. And we will get to, some of the details of this in the process. So yeah, we let's look at, what are some of the key factors now into selecting an LLM. And there is really, four main areas or pillars that we look into when we want to select an LLM. And performance, of course, the technical and business side of the problem, and the security of it. Usually, these are the different aspects we take a look into, and we are going to cover each of them one by one. So, from a performance standpoint, what you really, want to is how well does your model perform in terms of performance. You have things like what is the context length in terms of how much information can the model remember while you're working with it, and this can vary quite a bit. For example, as far as I know, Gemini, the Pro series is about I think they're like 2 or 1.5, or I think recently 2.5. They actually can support up to 2 million tokens. So very large context window. And then some of the smaller models can only support maybe 120K or up to 400K context window. So you do want to understand what the context length is based on your use case. You also want to look at how reliable and accurate are the outputs of the model. Depending on your use case, not every use case might need, reasoning capabilities. So you want to understand, does your use case require reasoning, complex reasoning? If you're, for example, solving mathematics at the PhD level, you probably need more, math type, have the capability of solving math type problems, or deep logical analysis, where you need to go through a lot of details to understand. So, but do we actually need all of those capabilities for every industry? Not necessarily. And another thing is like, now how do I know like my model is good enough? How do we evaluate how the model is performing? And so we can look at some of the and we will show the LM arena, which is almost like the unofficial benchmark source for all of the different LLMs. So that's something you can take a look at, and they have a listing with different scores based on different use cases. So that's actually a good place to look at. It gives you a little bit of understanding of where did these different models fall in. But I would take those, with a grain of salt, and really, we want to again look at our specific use case and what we want to do. You need to do your own testing, put the model to test in your own environment, and then come up with a final assessment. All right, so moving on to the technical standpoint. From a technical standpoint, you definitely want to look at the latency because it will become very critical if you have, real-time application. Let's say if we are building a chatbot, maybe it's a live chatbot for customer service, where maybe you have live customers asking questions, or they may want to look up an order and have a question about it. That's where speed and response speed becomes critical, versus if you are doing like batch processing, where maybe you are doing some language translation, you have documents that you need to translate from English to another language. That doesn't matter so much. You can wait maybe a couple of seconds more, and that doesn't have to be real time. We can run just run this in batch versus single query. So a lot of the closed source LLMs provide these capabilities, and and if we do batch tokens, usually it tends to be less expensive compared to real time or on demand. So that's something that if we have batch use case, if we want to try and see if we can leverage batch option to help lower our costs as well. And you also want to look at the scalability issue at different, like there may be different providers, and you're directly going to one of the LLM providers, whether for example that's OpenAI or Anthropic or Grok or Gemini. They do have restrictions on your transactions per second, TPS, or how many requests you can have, concurrent requests submitted to their API. So you want to look at that as well, because that will actually impact how the end user experience will be for your application. You also want to look at some of the infrastructure requirements. I mean, this is if you're going to, or if you're going to, host the model yourself, or whether you're just using an API, then it may not really matter much. But if you're running the model, if you are using it for inference, maybe on your own infrastructure, you would want to make sure that you have the right hardware, GPU hardware for being able to run the inference on. And then you also want to look at what are you really deploying and hosting options. So do you want to deploy this in the cloud? Do you want to on-prem? Especially, some of the larger organizations still have some on-prem presence, unless, for startups or smaller organizations, then we have to look at either cloud or hybrid. And finally, the APIs, SDKs, most of the major mainstream providers, they have APIs and they have SDKs. So they are generally very compatible. And these days, what I'm seeing is that a lot of model providers support let's say OpenAI API. So you can actually just install the standard SDK, OpenAI libraries for whatever language of your choice, and it could be any model under OpenAI. So for example, if you're used to programming with OpenAI, then the same code will just work. So you just have to change the base URL, update the model name, maybe update your tokens. And so this is something that we are going to observe happening in the industry. And moving on to the business standpoint, um, we touched on this topic a little bit earlier. You would want to look at the pair token pricing, and these do vary. There are variation in both like input tokens and even output tokens. And generally, output is more expensive than input. So you want to make sure you do your due diligence when it comes to what the token pricing is, and if you are going to be hosting this model on your own infrastructure, whether it is in the cloud or elsewhere, what are the costs for that? The other part is the development and integration cost. You want to look at the big picture. For example, you want to look at the total cost of ownership, which really includes everything. It's going to be hardware, software, development, and training. So it's that big picture from an organizational standpoint. Like if you have like a business leader, um, making wanting to know like what is some of the decisions they're going to make in terms of picking and making some of the LLM choices. A lot of us probably have seen too many reports in the news where the number is like something around 75 to 80% of businesses are not seeing value from their investment, and that is like what we want to make sure that we do the right due diligence from vendor and ecosystem perspective. You would want to make sure like what type of support you're going to get if you're going to use like an open source model. So there are a lot of vendors out there and they will support open source models, but you want to make sure if it's community support, or are you really getting like some sort of vendor support. What does the documentation look like? What is the feature roadmap alignment? Is the vendor even stable? And this is a space that's really growing really quickly. And there are a lot of startups in this space, and they have a lot of open source models. And they're adding their own either fine tuning or their own like uh, touch secret sauce to it, and basically making those models available for us. So if we are going to pick one of these smaller companies, we want to make sure that if, for example, they get acquired, we have a clear picture of the contract. What are we going to get out of it? What is the roadmap looking like? And yeah, so we should be ready for any transitions that these companies may have. Finally, as a security engineer, this has a special, interest for me. We need to think about security and governance, and this is something that you have to really read about the privacy guidelines and the security guidelines for each model and each model provider. So this is where we really need to do our homework, and with a lot of paid models, and if you are actually going with one of those closed source models, if we are generally like paying for the API, or if our company has some custom agreement with those companies, they generally do not use your data to train their model, but that is something we want to make sure. And what is it? Read the T's and cross the C's or something like that, the terms and conditions, to really understand how is your data really being processed, where is it stored, who else is using the model, is the model that we are, is this like what model we are accessing to? Is that model dedicated to your organization? Is it shared with others? So there is a lot of data and access controls in place, and we would want to figure out how it's actually working when it comes to the provider and where this is being hosted. We also want to see what sort of audit trails you have. Like most organizations or industries are regulated, whether we are in healthcare or whether in banking, finance. I'm sure for manufacturing as well, we have different regulations, and every industry has their own set of rules. So we would want to make sure that from a compliance perspective, you're actually checking all the from a risk perspective, checking all of the details. So all of the models also have some bias, and it's really based on how they are trained and what data is used in their training. So this is something that, when we run some tests on the data, sometimes, we get a better evaluation whether the model is biased or not. What does the answer look like? These models have, rails to prevent toxicity, to prevent harmful content, but that's like something that we definitely want to test to make sure through some sort of, intelligent prompt injection. We may not be able to make sure that we are not able to break those guardrails and sort of, have the model do things that it shouldn't be doing. So again, this is something that you definitely want to explore and find out whether the outputs are consistent. And also consider that the outputs is like most of the time probabilistic. So with a little bit of variation, do we see consistency in the output or not? So basically, we are, if we are looking to select, a model, we shouldn't really, get caught up, with what we hear in social media or, what we see in the mainstream media. Um, we want to try to, shut, some of the noise down and really make a data-driven decision using some of the concepts that we talked about and across different categories. You really, want to focus on the total cost. Many organizations have ignored this, which is why they have seen like their costs sort of go out of control. And the other thing is that they usually don't test with real data. You want to use your real data to test the quality and find out what are the security considerations, how is your data being used, what does the access to the model look like, and of course, the fact that the biggest model is not always the best model. So we'll talk a little bit more about how you do sort of pick up the right model and then really aligning it into your roadmap. Instead, you really want to work backwards, starting with the business requirements and then move from there. Most of us are tech people, and we usually get caught up in technology, and we do want to work with the more advanced, the biggest models. But you really, we want the right thing to do is to start with the business requirements. We want to see the real use cases that will be impactful. And then, of course, given how fast things are, we do want to have a plan for changing it and scaling it out. All right, then moving to the next section, we can talk about a framework we can actually use for choosing the right LLM for our use case. And that is actually contains four main steps in terms of an LLM selection framework. And so you can see it starts with requirements, and we need to have the requirement gathering phase. And we encourage, a lot of people and a lot of, customers to spend their time, most of their time, in the requirement gathering phase. And once we do have a specific set of details about that, we can actually move to the evaluation phase. And this is where we actually want to test with real data and go through all of the details, and then go through, of course, the deployment of the model. So we can take a look at all of these phases together. So starting with the requirement, you really want to figure out what use cases or what business problem is the LLM going to solve for you. What are the specific tasks that the LLM is going to perform? Is this going to be used for summarization? Is this going to be used for customer service chatbot? Is this going to be generating code? So you want to figure out what exactly are the use cases, and you want to define success metrics for each of those use cases. What would look good, and it's, without having the right success metrics, it's going to be very hard to measure and evaluate. So which is the next phase of our work. So we would want to understand what is the user experience going to look like, especially if this is going to be, a real-time model where someone is going to be interacting with in real time. You would want to look at something like response time. What does the UI interface look? How does the service integrate with other systems in your organization? In most cases, these LLMs, they know generally, have to work with other systems in the organization. So we really want to understand what does the integration framework look like. Uh, Another aspect is volume expectations. We really want to know what sort of load we are expecting to the model to generate. Is it going to be, some translation requests? How many transactions per second or per minute are we expecting? What is the growth rate in this case? In real world, we do have constraints that we have to deal with, and we have seen, the number one of, these constraints that we have seen in different conversations is budget, of course, in different organizations. It seems to be number one concern, and you would want to know what sort of budget constraints you have, what is the timeline for your business stakeholders, when do they need it, they need the model to be ready. And again, another point is the security and compliance requirements. And if we are in a regulated industry, then those regulations, what are those regulations, and how are they being translated into our solution? And then, what are, the technical requirements in terms of infrastructure and being able to understand the team capabilities, the capabilities of the engineers you are working with. So if you need to build some sort of a training or enablement program, you need to think about that training. So there is like a high level evaluation matrix, and these are, just some samples. So yeah, you can adjust this based on your use case, and you can also adjust the weights as you like. But this is like a simplified version. But at a minimum, you want to have at least 5 different categories of performance, cost, latency, security, and support, and then assign it different weights. And then if there is, if we have like model A, model B, model C, you can really, give them different grades, different options. And this is where you would put your evaluation numbers in, and you can look at through the numbers and make a data-driven decision, which is our goal here. So Yeah, then in your pilot, basically, you would want to pick a few edge cases, and this is where you're making, you'll be able to handle any sort of errors or unexpected behaviors or even boundary conditions that you may have in the model, and you would definitely want to involve actual users. So but this is a mistake, I have seen many organizations do. It's like run it through an IT organization or IT team, and they sort of, just tend to just move on without, sharing it with any real users. So it is important to involve users early on, get their feedback, and sort of use that as an iterative process to build out the testing and evaluation strategies. Um, in terms of success, there's like both quantitative and qualitative measurements that we can look after for success. You can look at things like, if the response time is important to you, if the cost or accuracy is important to you, how would you basically measure those and document those? And then from a qualitative perspective, it will be like ease of use, or how does it integrate, or what is the user satisfaction. So those are some of the things that you need to make sure as part of your evaluation process. So if things go well, and you have picked a model, you would want to make a decision at this point. And this is where you would want to basically use the evaluation matrix and make a data-driven decision. You will look at all of the results, you will look at the overall alignment and roadmap, and how this fits into your overall future state. At this point, you are now looking at the implementation phase, and so that's basically uh, figuring out how do you come up with the final architecture, how do you work through different integration requirements, how do you work with security and governance. Maybe you need to build a training plan for people, or maybe you have to learn a bunch of new skills. And then you would look at you look at and operationalizing the whole model, and create a support process for that as well. Um, all right, so um, I see a bunch of
I'll take it from here now for the next 5-10 minutes, but I think there are a lot of questions that come your way. Be
yeah,
it in
I'll
chat. If you want to address one or two right now would be helpful as well. That's also okay. Um,
you
just
can go ahead. I can respond in the chat as well.
got it. Folks, firstly, I think there are a lot of questions in the chat around the AI Launchpad. Let me share my screen once. Neither if you could stop sharing your screen, I'll be happy to share it once. Thank you so much. Yeah. So, yep. What happens with my screen sometimes? Yes, I think there are two, three questions that have come for the Launchpad piece. Resharing the poll. First, with people that the poll was too short, hence resharing the poll. Second is to clarify on the dates. It's on 10th, 11th, and 12th of October. It's not mandatory to attend all. You can attend some sessions based on your liking. This is one. Timing is 4:30 p.m. Pacific to 7:30 p.m. Pacific every day. Each session is a 90-minute session. It will have live demos, the repositories, everything for the same thing. People say like, will we get recordings? Will we get the slide decks for the AI Launchpad? Both will all will be shared. That brings me to a very important question. I was thinking of creating a channel to communicate with folks who register for events such as these. Is Discord a better, if we start a Discord community or a Slack community, what would you folks prefer? If you could just drop in something on the chat, that would be super helpful. Folks want to look at the agenda, like this is the agenda. While you're looking at it, I'm just checking. So WhatsApp and Teams channel we don't do. WhatsApp is fairly strictly professional, personal reasons. We don't get into WhatsApp. I'm seeing a lot of people texting Discord. If you could just very quickly, I'll just do like a cloud sort of a thing. Sure. I think Discord is the clear winner over here. We'll set up a Discord community. We'll send invites to you folks. What I'll do is for two predominant reasons. Any masterclass going forward, I'll ensure the slide decks and everything are there with you on the Discord community. Maybe not this one, please forgive me for that. But from AI Launchpad event and onwards, because we have the full calendar for October and November decide, there's something I'm not sure if a membership that you keep the recording that and that has message board for asking questions. And that is a good suggestion. I'll pick you up on that, by the way. But we'll have the recordings, the slide decks, repositories, all the content you need on Discord. Just give me like a week's time to set things up, ensure like the things are being taken care of properly internally. So we'll get that rolling. Maybe some folks might miss out from this. And yes, Syed, once invite comes your way, feel free to share it with your friends. We would love for it to be shared with your friends. There's no fee attached with it. It's just like your community. You can share it wherever you want. And I might hit you up for this, bro. Thank you so much for this. Coming back to this, I'll quickly move to the content. Poke the poll is on. Feel free to respond to it. Um, I won't take a lot of time. I think Nahid has still a lot of content to cover, so I won't act like as a blocker. Uh, who am I sharing with? Sorry. Yeah. Coming to Interview Kickstart, I'll very quickly walk you through who we are, what we do. Uh, like I mentioned, we are a go-to up-leveling platform. Interview prep and AI up-leveling are the key focus areas. We do have a B2B offering as well. If anybody has any question on the B2B, do drop me an email. I'll share my email address as well. Uh, what I'll walk you through in the next 5 to 7 minutes is how is the market shaping up, what are we seeing, and quickly use that as an opportunity to plug what courses we offer. So in terms of what the market is looking like, so I think essentially what the industry, and it's a very common saying also, right? Go where the money is flowing at the end of the day. So in US or worldwide for that matter, companies are investing like never before in AI. And if you were to look at where that money is getting invested, definitely right now, a lot of that money is getting invested in the AI infrastructure, then the model development, then the industry specific solutions. So the split is 40 to 50% for AI infrastructure, 30 to 40 for model development, and 20 to 30 for industry specific solution. I think in Q1 itself, FAANG Plus have already invested $53 billion. And I think they are like really well poised to ride this AI wave already because of the big deep pockets they have. Again, we work very closely with LinkedIn. This is data that we work with LinkedIn, get their internal research out there, what like how many job postings they have, what are they seeing out there. What we have seen is there's a massive job growth in 2025 in AI ML roles, almost 1.65 times in 2025. Along with that, the associated domains like data engineering or data science, they're also growing. So kind of like ties really closely well with where the money is flowing and where the jobs are eventually happening. And eventually, and more than that, it's not just the core roles. You will see emergence of AI preference in traditional tech roles also, be it engineering managers, be it program managers. The skills are being asked for over there as well. As a result, people who are early movers in this particular domain, there is a significant salary gap between people who are in the traditional roles versus AI enabled roles. And that salary gap increases definitely as you move higher up the ladder. The gap bridges between much more. And what we are calling it as internally is AI ML surplus compensation, which is where the bridge is coming from. Uh, and I think this is one very common thing. People are saying there's so many things happening over there. And it's a, we do understand it's a very challenging path. And it's not that it's like impacting every role in a similar manner. It's impacting most of the roles in a very different manner. Um, as a result of which, if I were to say like again working very like just to say like give me one sec. Yeah, 1 in 4 SWA roles are now seeking Gen AI expertise, whereas when it comes to engineering managers, the prevalence is a little bit lesser. Almost 20% roles are seeking engineering AI enablement and engineering manager roles. If you were to look at all the new JDs across new roles, 10% of new JDs are now mentioning agentic AI. As of, I think this is 1 to 2 months old. The prevalence has increased much more. So it is impacting all roles unequally, and it's creating a lot of confusion. And I think there's one thing that I'll just running one very quick poll. There's something that we see once again, AI. We call it the 4 stages of AI. One is a person says like I can't do AI because it's moving too fast for me, and some people say there's just too much out there. There's just too much clutter. I don't know what to choose. And in terms of some people have this perception, maybe right for that matter, that their job is unique and safe, and they don't need to like upskill as of now. And then there are people who have this very major perception where say like if I learn AI and if I have to transition, I might have to down level. For example, let's say I'm at like a staff software engineer, I might have to move to one level below or something of that sort. So these are the common things that are coming across when we speak to different people. So I thought I might run a very quick poll over here. And something that is really, really common already for me is AI is moving too fast for me. 27% of the respondents are saying that. 40% are saying there's just too much out there. And then there is definitely the 21% who are saying I'm already ahead of the AI curve, and that kudos to them. But we do believe at Innovic Kickstart in general also, like upskilling is the way to stay relevant, and just where the money is going, follow that path, and I think you'll be secure for the next few years. Not to like cause any fears or anything. Again, I don't think I'm even like uh, poised to do that. So what we have done is we have created like a proprietary AIQ framework. I think just do this activity for yourself. It will help you also. What we do is we have this AIQ framework which we have built internally, which we test folks on. We believe in terms of the AI up-leveling journey, there are multiple stages. The first part comes around augmentation, wherein people are starting to work with LLMs. They are working with they are improving their productivity with AI co-pilots. And then we call the next phase as transformation, where you're building complex AI agents, where you're building on top of advanced ML models, and then where you're building ML complex ML models as well. At Interview Kickstart, we don't cater to augmentation stage. We believe again we do host these sort of sessions but from a curriculum perspective, we don't cater to the augmentation side of things. We believe most of us are well equipped to do take care of working with the LLMs and improving our productivity. But when it comes to the building complex AI agents or building on top of advanced models or complex models is where we come in. And as we move upwards in the AI up-leveling curve, one thing that we see is the complexity involved, the time involved, the coding skills involved, they increase many folds. Depending on where you want to be or where you are, there are certain roles you can target. For example, if you are already building complex AI agents or Gen AI apps, you can definitely target AI software engineering roles. You can definitely target AI product managers, AI EMs, or AI TPMs. Coming to modern ML, somebody, let's say, who's building on top of advanced ML models, there's a new role that have come up in the market recently is modern ML engineers who are working with complex models. They're not building them, but they're building on top of it. And then definitely we have the traditional deep ML engineers who are working on deep advanced ML, who are working on AI research predominantly. And so basically, I think this is like gives you like a very quick flavor of based on what skill sets you have or what skill sets you want to acquire, the kind of roles you can target. Uh, Again, for example, somebody is in the early stages of LLMs and they want to move up the curve. We do have different courses. For example, somebody wants to build complex AI agents in Gen AI apps. Edge Up is the course that we offer. Somebody wants to build on top of advanced ML models. Flagship ML is the course that we offer. And somebody who wants to build complex ML models, advanced ML is the course that we offer. Mhm. I'll be running 1 second, Matt. I'm so sorry. Yeah, I'm just launching a poll. Feel free to check it. I'll be revealing the prices also very soon, just so that you know. Again, coming to the Edge Up, what does the Edge Up entail to? Edge Up has two core pieces. One is Pro Code and Low Code. Pro Code is more for IC role people. For example, somebody who's a backend engineer, full stack engineer, AI engineer, who are working very hands-on, who are very hands-on with regards to coding and have a software background. It's a 6-month course, And edge up low code is mostly for people who are a little bit in the management positions, so that they are well versed with agentic AI, and they can build agentic AI, agentic and Gen AI systems. And also, it comes with a very strong flavor of interview preparation. So it has two pieces: upskilling you, and then if you want to prepare for new roles, crack new roles, will be helping you. The tools covered are mentioned on screen. I don't think I need to go into that. If it's about modern ML roles, it's a flagship ML program that we call. It's a 7 plus 2 months program. And like I mentioned, right, the time required for the more you move up the up leveling curve, the time investment required per person increases. Because it becomes more hands-on coding, it becomes much more complex. You need to be much more in depth with regard to statistics and mathematics as well. Again, it's a 7 plus 2 month program, 7 month on the core concepts, 2 months around interview preparation, wherein we help you with tier one interview preparation, resume LinkedIn optimization, all those sorts of things as well. However, there's one core thing is that we help you build a multi-project portfolio under FAANG Plus Mentors. There's one thing that is being constantly asked in the market is demonstrable AI skills. And people are working with regards to AI related projects in their work streams already, but the plethora of projects they are working on is limited. So working on projects is something that we help people with build their portfolio around, and that is a core part of all our courses, be it edge up pro code low code, be it your modern ML, and then be it your deep advanced ML program. Again, advanced ML program is 12 plus 2 months. 12 months for building the core skill set, 2 months for the interview preparation. Again, it has like, I would say it has capstone projects, 50 plus assignments, so that you have like a full-fledged portfolio built. It starts with, let's say, course starts. Then there will be like one second. There will be assignments. There will be a mini project, then multiple mini projects coming your way. Then there'll be capstone projects. Again, you can pick and choose which projects you want to build. For example, somebody's from health tech domain or somebody's from fintech domain. They can pick projects based on their domains, so as to show relevant skill sets with relevant projects to future recruiters or just to build their profile or learn for that matter. In terms of a solution, like I mentioned, these are the core courses. Just a very quick summary: Edge Up, Flagship ML, and Advanced ML. And the timeline ranges from 6 months to 7 plus 2 and 12 plus 2 months. If somebody who doesn't know or is very early stages and if want to explore, I think Edge Up is what we would recommend because it doesn't require very strong coding skills and it helps you stay relevant in the market. Coming to the pricing, again, these are list prices. Edge Up starts from 8,900 USD. Flagship ML starts from around 9,500K USD and 9,500 USD, and advanced MLE start from around 12,000 USD. Again, these are list prices. We give money back guarantee. We have alumni scholarships. We have financing available, and you can enroll now and start anytime. If you would want to know about the offers that are there with regards to the listed prices, feel free to get in touch with your program advisors. Coming to the last aspect, and apart from the AI ML pieces, like we have like those courses. In addition to that, somebody is like, there are a lot of you are saying like, I'm already ahead of the AI curve. Great. But maybe if you're looking for courses or structured curriculum that help you move from, let's say, a tier one to tier two to tier one firm or 5 plus companies, we have interview prep courses as well, which cater to more than 18 domains, and it is layered based on what role you're coming from, whether you're early engineer, whether you're manager, or whether you are experienced IC, and also dissected by which domain you're from. Again, I think one key metric any edtech company or edtech solution gets, I would say, evaluated on. What is the salary increment that you would get out of it? What is the ROI of my investment? What we see internally is the typical minimum salary increment is somewhere around 75,000. Typical maximum is somewhere around 150K, and upward of maximum is somewhere around 835K is what we see. Again, yeah, these are more on interview preparations because people choose to upskill themselves in AI and not look for really jobs perspective. But these are more from interview prep side of things. I think that is all from me. Uh, Nahid, I think over to you, I would say. Let me see if there are any specific questions that have come my way. Uh, Daryl, accredited university, I would say we have enough. We have been operating it for more than 10 years. We're not a university. We are specifically a solution that cater to working professionals, which is built around their flexibility and built around keeping their requirements primarily. How do we get the folks? Yeah, for the AI Launchpad, just drop in a yes right now. Within a week's time, I'll send the invites in your email. You don't need to reach out to the ops team. I would. The poll was for me to record your responses. Uh, I think for the pricing, somebody saying, Nahid, can I reshare once? Or you can move back to the previous screen. Can you move to the previous slide if it's okay with you? The pricing slide. Sorry for this. The one before that. The one before this. I think. Let me share if it's okay. Hey, thank you. Sorry for this confusion. Appreciate it. Um, yeah, somebody was asking about the prices. These are the prices. Again, these are listed prices. Like I mentioned, there are discounts on top of it. If you're an alum, there are furthermore scholarships, and interview prep courses are on the much lower side. But flagship ML are like year-long, 9 month sort of courses. So hence these are the prices. And again, like I said, financing is available. We have payment partners, Klarna and Climb. You can enroll now and start anytime, and there's money back guarantee as well. I think it addressed somebody's concern around the pricing. And there's poll for if you would want to know more about it, the poll is on. Nahid, over to you. Nahid, if you're speaking, you're on mute, by the way.
Oh, sorry. Thank you for letting me know. Yeah, I was just saying that thank you for the questions. I try to answer the relevant ones to the LLMs basically, and some questions are about the communication through Discord. If they're going to get the slide deck, which I'll let you answer to those questions. But at the moment, we do have a couple of more slides, which I believe are the more interesting ones, in my opinion. So far we have learned on how to select a model and how to move towards deploying it. Now let's take a look at what does really fine-tuning mean, which is why we are all here, and how does it compare and contrast with RAG, Retrieval Augmented Generation. There was a question about online fine-tuning as well. One of the answers is could be RAG. So when it comes to taking and then taking a model and then injecting it with domain-specific knowledge, there are really, two different approaches. We can either fine-tune, which means that you have a specialized data you use to train your model, versus a retrieval augmented generation, which basically you are having your model do a lookup, or actually you're having like some code that sits in front of your model, do a lookup to some sort of external source, and then it will be able to retrieve some information, and then it can be used to inject and add more context into the model, so the response is more grounded. And we'll take a look at what these two approaches are. And when we look at, fine tuning is really a way to adapt an existing LLM without retraining it from scratch. So really, when you look at the purpose of fine tuning, it's really to add domain specific knowledge. And for example, a lot of the models have like industries have very specialized terminology. They have some jargon or something, and this could be like a company jargon, maybe not even an industry level jargon. So your model technically may not know what the context or what are those words really mean. And so maybe like a regular sounding word really has a specific meaning in your industry. So in this case, fine tuning is really a way to train these using domain specific data. You can also use fine-tuning to adapt the style or even the personality in terms of how the model, in terms of culture or it behaves, in what language, in what style, so it matches your organization, and then you could really optimize it for some very specialized task. And we will have a demo shortly that shows this use case. And when we talk a little bit about, fine tuning, which is technically embedding knowledge directly into the model. But when we look at RAG, it's a mechanism where the LLM basically gets external documents during its inference time. So when a question is asked or when a request comes, into the picture, there is usually a piece of code or an application sitting in front of it. And this is where this code is actually performing the RAG or the lookup phase. And it's getting knowledge maybe from an external database. It could be doing a search on the internal or querying an internal system. And so that's basically kind of like augmenting and sending the information to the LLM so it can actually give a more grounded response. And in reality, it's not an either or decision when it comes to fine tuning versus RAG. You can actually go with the hybrid approach, and this is what we usually like do. We actually do both of them. So combining both gives you a better accuracy, and you are going to have like a fresh and accurate data, and it gives you better resilience as well. Um, Sorry, trying to move to the next slide. All right, so there are some myths when it comes to fine tuning, and people talk about fine tuning doesn't add new knowledge. It actually does. Fine tuning does add new knowledge because what it really does is it goes through the different parameters and then it basically looks at the neural network and then it only modifies certain parameters within the network, and it does add new knowledge as part of adding those neurons. You may also hear that RAG is always better. It's not necessarily true. It really depends on the use case, and we'll actually look at some techniques that you may hear, like fine tuning is too expensive. And that used to be the case, but in the past, fine tuning was a process where it involved a lot of compute and then lots of specialized ML practitioners. But now there are different techniques in which we look in a little bit. We have LoRa and quantized LoRa, um, which is QLoRa, and they are actually efficient and cheap ways to fine tune the models. So what is LoRa and QLoRa? LoRa is a technique where you could fine-tune a large language model by adding a small trainable adapter. So typically, if you were to fine-tune or do a full fine-tune of the model, that would be very expensive. It takes a lot of data, lots of compute. But when you use LoRa method, what it does is that it doesn't go through every parameter. So if your model has billions of parameters, it actually goes through a few of the layers of your neural network. And then it only trains a few of the adaptive layers in your neural network. So it is more efficient. And there is only, so when we look at, the quantized LoRa, it's basically LoRa where you reduce the precision and you might also lose some amount of data because you're going down from 16 bits into 4 bits, so you will lose some information, but you have the ability to run your fine tuning on like cheap hardware, commodity hardware. You don't need very large monster GPU hardwares. And we do have a demo. I want to share my screen. Hopefully you can see my screen. So, right. Okay, so in this demo, I'm running it on my Google Colab and I have it open. I actually ran all of the cells. The reason is that the training actually does take on Google Colab. I'm just using CPU, so it does take about like 20 minutes. We don't want to wait for that. So just so you know, in the first cell, we have we are installing transformers. It's an open source library developed by Hugging Face, so you can think of Hugging Face as the GitHub for machine learning. And then we are also going to use transformer reinforcement learning library, and then the Hugging Face hub as well. So I did install this. It is easily installable, at least in Google Colab, very easy to install. And this cell is actually trying to log in to Hugging Face. So if you don't have an account with Hugging Face, it is free. You can easily create an account, and you can also create an API key. You need to be careful to copy your API key, otherwise you will lose access to it, and you have to either delete it or refresh it to get a new key. So in the next step, in this step, we are logging into the Hugging Face, because we are using one of the Hugging Face models. They are free. The Hugging Face is a great resource where they have literally, hundreds of open source models available. So you can even download the models, you can use them locally, and if you want to use the inference through one of the providers, you can also do that as well. But any work, in the open source community is through Hugging Face. You even have the capability to push your model to Hugging Face. So then after logging into the Hugging Face, we will have to paste our API key. And this is like we just do it using the free account. It's not, paid or anything. Then I am importing the Torch library, just so if you have CPU, or if you are using, I believe this is for Mac OS, or GPUs available, you can enable those and use them as part of your fine tuning. And then the next step is that basically we are using the Transformers library, importing a couple of libraries here. And you can see that we are importing the tokenizer library and a model for, some casual LLM. In the notebook, we have some examples of different LLMs that you can try, and you can easily have access to them for free through Hugging Face. As I said, models don't understand text. So what the tokenizer is actually doing is that it takes the text, any text that we provide, and then it converts them into tokens that the model can use. And that's really like what we call as a tokenizer. You can see I was actually in the morning was trying the small LM2, which is an instruct model, and then I tried another instruct model from Quen. Yeah, so the thing with, instruct models is that all of the instructor models are basically good for chatting. So if you have a chat use case where you can ask a question and get an answer, that's what the instructor model does for you. Because they are trained on top of the base model on an assistant model as well. For example, can you use a really, really large, 70 billion LLAMA model? Of course you can. You just need to make sure that you have, because we want to fine tune this, you have to make sure you have the right GPU with enough RAM to actually fine tune this. So that is why I picked a small model, so I can easily run my script here. So you can, set the message variable, and we are doing it basically giving it a role, and we are saying that who the model is interacting with. I'm also giving it some content, and the use cases in our example is through a healthcare use case. And the question I'm asking the model is like, hey, I'm a 35-year-old patient, and I have fever, and can you just, summarize this thing? After execution of the model, you can see that interestingly, the tokenizer, is tokenizing the message and it is configuring the model, and then it generates something that is really not too relevant. It even talks about, COVID-19, um, and irrelevant data in this case. So, and like if you try the LLM AMA instruct model, it actually tells you because of the guardrails, it will tell you that I cannot provide any answer to this because I don't have enough information. So give me some details and then I'll try my best to help you, something like this. And this is, the basic response that we get. So what we want to do is that we want to actually take this model and we want to be able to almost make it like a doctor assistant, where if I were to ask the same question, I would actually get relevant answer. For example, instead of, saying, giving it, like saying you have COVID, etc., there, or saying I can't help you, I want it to give me some actual answers. So what we do in case of, fine tuning is that we are providing a JSON file with all of the healthcare information and we are loading the data. You can see the consultation and the summary. One thing that I told in the lecture slide was that sometimes we want a specific format. So, and that is what fine tuning help us because output tokens are expensive. So you can see in the answers that is provided as summary, actually the format is very specific, gives heart rate, BP, some sort of, complaint or assessment with it. Um, and so we provide this as the source of our data. And then we go to the next step. And that is kind of like these things really happen quickly. In this case, we have very small data sets, only 100 cases. And now we are going to use the transformer reinforcement library and we're going to set up a supervised fine-tuning configuration. And if you notice here, some of the hyperparameters we define in the configuration and they are in the config file that we provide. So this is our configuration. And some of the hyperparameters here are will be exported to our output directory. We do have a small directory, so when we start from here, we just have, this JSON file, and these are what created as a result of our fine tuning. So then we move to running the training, calling the train function, and then we are actually running, for example, 3 epochs in this case. And so the epoch is really the number of passes the fine tuning would take as it goes through the data. There is generally, if you have, higher number, you will get better performance, but it will take even more time. And then you have, pre-device like train batch size. We have learning rate, and you can see that, it's very small, like point zero, but like followed by 5 zeros and maybe a 1 or a 5 in this case. And that's basically what the learning rate is. You would adjust it based on your hardware. Um, yeah, so just because I do have like cheap hardware, I'll just run much better with lower training rate in my case. And then you have, quantized LoRa, and the default is 4 bits in quantized LoRa. So that's why I have the number of for floating point set as false in this case. So it's actually has even lesser precision, but it's easier for just training quickly. So, we are basically constructing a fine-tuned model. And so there's like a consultation and a summary field that we want to feed. And that's what we want the model to learn that should be the format of the response. So we are passing the config file generated, and we are going to give it, what model it needs to create, the name of the model, and what will be the training data, and you have to tokenize the training data, and Yeah. So this is the phase that takes long time. The good thing is that you do get an API and you will have the capability to push once you fine tune your model, push your model to that API and load it at a later time. But you can see how the training loss is actually becoming smaller and smaller. And you may run out of memory, like if that is why I ran it on Google Colab, because I was having issues with memory on my own computer. And so then you can save your model, you can push your model to the Hugging Face if you want to, or you can load it from your local directory that is created here. So you can see that I'm going through all of the steps that I went. We went through the tokenizer, called the model, and we do have, some temperature, etc., some other hyperparameters, and then we'll pass the same prompt. I actually tried it with two different prompts. One of them is like 50-year-old, one of them is 35, and the fine-tuned model is actually generating a summary based on what we fed it in as a formatting of the JSON data. So still, like, it is a combination of what we fed as fine-tuning and a combination of what it used to do previously. So for example, you can see it has like vitals or electrolytes or medications, etc. And some of the fields in the JSON have this format, some of them have just directly BP, etc. But you can see how the model is actually fine-tuned in this case. So yeah, basically that was the demo of the fine tuning. I did take a couple of screenshots in case the model doesn't work or I can't have the capability to show it. So basically, what we talked about is we covered the different types of, LLMs and what we should consider when we want to select a large language model to deploy. We talked about fine tuning and we talked about how it is different from RAG, LoRa or QLoRa help with making fine tuning cheaper and faster and more practical. And technically, or based on my experience, like the best of the both worlds is to combine these both of the methods. And with that, thank you, everyone.
Thanks, Nahid, for taking this up. Just one thing. I think there are a lot of questions coming regarding the link to demo and all. I'll have somebody send them your way. Folks, just give me like a week's time. I'm not like sure if we are supposed to share the demo or not. Again, I'm working internally with regards to this. Just give me like a day's time. I'll clarify if we are. I'll happily send it your way. I don't have any qualms about it. But just give me a day time to like, get that confirmation internally. Um, apart from that, the recording for the session, I think will be available in a 2-3 weeks time frame because the video will go into some editing, then my portion will be completely edited out. The core content would be in the picture, so you don't have to go through the fluff when the recordings come your way. So just give us like a week, 2-3 weeks time before it comes your way. Any questions anybody has? I think there are a lot of questions which have been asked. Nahid, would you want to pick some up if you have like a few minutes? Otherwise, I'm happy to end this straight away. I think your screen is.
Yeah, absolutely. Like, why are we choosing fine-tuning rather than RAG to feed the data into the LLM model? Is because in case of RAG, depends on the nature of the data as well. We want the model to be retrained in order to pick up the new format. We don't want it to just use this information. So, for example, maybe this information says for 35-year-old the like fever level or heart rate is 100, something like this. We don't want it to always come back to us and say with 35-year-old heart rate is this. we want it to pick up the formatting and the information that it provides. If, for example, in case of RAG, if the data is like unstructured or large scale, it is better to use RAG in these use cases. Um,
I think
is
there
it
is, what is the use case when RAG is not an ideal way and fine tuning will fit in?
Yeah, so for example, fine tuning is when we want to for structured data. For example, in my daily work, we do have like we are building assistants for privacy reviewers, and we want the output to be in a specific format. It's a threat model language format, and we can easily create, data flows. But if we want it to be in a specific format, the fine tuning part will help with that. The other thing is if we want to give it, really, really specialized information, let's say specific domains like industry, healthcare, financial, etc., which like the model, have like a lot of basic knowledge from the internet, but we want it to be specialized is when we use fine tuning.
Jeff, we would definitely be interested in speaking about the latest trend in MCP on a later date. I think our calendar for October is pretty packed. Maybe in November first week, we'll definitely pick that up. Now, Nahid, how many more minutes do you have? Otherwise, we can end it right now if you want to like one or two.
Just answering one more like
Yeah, then we'll end it.
one question in the demo is that the BP number shown in the output is hallucination or sample. It is because of the formatting that we fed it. So it is not a hallucination. The model is actually looking at all of the information that we fed, and it probably picked up what is the rate of, the different BP levels that is part of that data set.
Cool.
The
Thank.
original output
Sorry.
that had like COVID, etc. in it, that was hallucination.
Sorry for the
Yeah,
faux pas interrupting your flow.
no worries.
But thank you so much for taking this up.
Thank
Folks,
you.
thank you so much for tuning in. Again, three things that I might take away from the session are one, not from the tech standpoint, from action standpoint. One is to set a Discord community. Give me like a week's time. I'll send the invites your way via emails for folks who have not, who might not get it. That is one. Second is get back on the model, the link to the demos and the Python file, the JSON file. Just give me like a day's time. If you don't hear from me through email, then definitely you're not getting it. But going forward, I'll ensure we maybe after 2, 3 master classes have things that we can share, or shareable material is something that we do master classes about, so that you folks have some takeaways. That's the second piece. That being said, for AI Launchpad, I'll ensure all the materials that we publish out there is shareable so that you have access to those repositories with you. And the third takeaway, I think I'll get from the feedback which you folks are putting in right now. So there is a poll. I think if you have any feedback, I'll be happy to like address it. Gautam, once I create the Discord community, I'll be happy to share it over there, the slides. But I think home to God, if you don't get the link to, but then I'll ensure you get the link. I'll make sure it gets bombarded to you on your SMS, WhatsApp, or your email for that matter. You'll have the link with you. Don't worry about it. No need to reach out to the ops team. I'll ensure whoever has put in a yes today on the poll that they get the link. If you, so don't worry about it. And there will anyways be some invite emails, one drop that we'll still be doing to folks once the itinerary matures further. This was like very early thing. There's no website which is live. It will be live one day after. So once that goes live, you'll have all the things in your place. Thanks, Nahid. Really appreciate you taking this up. Thank you so much for your time. Look forward to seeing you for the AI Launchpad as well. And we would
Yeah,
definitely like to like do a lot more with you if your time permits and if you are up for it. Thank you so
yeah.
much, folks. Appreciate
Thank
it.
you for the opportunity.
Thank you. Have a good day. I'll be like, now you can drop off. I'll be live. People might be filling in the feedback. I'll just keep this thing live for another minute and then I'll stop.